Good evening all. Gayatri here. Welcome to Pantech e-learning. Welcome to Pantech e-learning. So first of all, I appreciate early comers to the section. So Pantech e-learning is the product, lab equipments company. So we have a microcontroller kits, processor, DSP, power electronics, interface cards. So we offer live course classes and 60 plus courses in programming languages also, and internships and projects. So we have several domains and research and development projects also in CSE domain and IT domain. So EC department and triple domains also we are handling. So agenda of today's image processing in MATLAB. So what we are going to see in image processing using MATLAB. So first of all, we are going to see what is image and types of image processing and techniques and method and applications of image processing. Okay, and then MATLAB installation process. So image processing toolbox in MATLAB. What are the toolbox we are going to use in the MATLAB and MATLAB Simulink? So fundamentals of image processing we are going to see. What are the fundamental like image conversion, working on histogram, image smoothing, image filtering, and building graphic user interface. Okay, and counter detection. So text detection on image using OCR. So image processing in MATLAB. What is image processing? So before we are going into the section, for example, day-to-day life we are using a phone, smartphones, right? So in that smartphone we used to take picture. For that purpose we are using the filter process, right? So after taking the picture, it's we are using the filter process. Before that we can why we are using the filter? For filter process only, before using the filter we have to change why we are using the filter, to change the skin tone, to enhance the image, to brightness, and to increase the contrast. So that purpose only we are using the filter. Before that, what will happen? Before into the pre-processing, before using the filter, what will happen? we are going to see the classification before how it works, how it classify the before the pre-processing section. Okay, first we have to go into the image processing. We should know about the image. What is image? So image is nothing but a two-dimensional structure. Okay, two-dimensional structure means it's formed by a lot of pixel. That is a combination of pixel. That's why here image contains 256 by 256. Okay, so it is I told you the combination of structural, maybe the structural of horizontal and vertical lines. Okay, so somebody will ask what is pixel. Okay, collection of pixel only. The image I told you, that is a two-dimensional structure. So somebody ask what is pixel. So pixel is nothing but if you zoom, if you take a picture in your phone, means if you zoom it means it will show the image that you can see the small square shape. So you can identify that as the pixel. Okay, so multiple pixel will be formed with the combination of rows and columns. That will be the matrix. Okay, that is called pixel. And 256 by 256, what is 256 by 256 means? It is the image size. Okay, image size of the pixel. So this is the pixel which I have told. This is the single picture which is converted into rows and columns. Okay, this is the form of the matrix image. If you zoom, you can see the square shape. Okay, what is the image? So what are the formats of image, file formats of image? We have a different file formats. First one is JPG, joint photographic group. Okay, next one is JPEG, then BMP, then PNG format, then TIFF and graphic interchange format. Okay, what are the types of image we have? So image types. Image types. So what are the type of image? We have a RGB type, that is a color image. RGB means red, green, blue type. Okay, so color image RGB type, gray scale image, and binary image or bi-level image. And you can say that black and white image. You can say that black and white image. So this is the black and white image. Okay, so RGB, taking a picture in the camera itself, that is itself a RGB color, RGB picture, RGB image. Okay, so the RGB is contain 3 array. Okay, so 3 array type, that's the 3 plane, that is a 3 array, which is RGB. Okay, by this RGB color only other colors are formed. By it's converting RGB by this RGB color only, it's converting the other colors will be converting. And its range of RGB is 0 to 255. So each RGB color itself for red and green, for blue itself, each single red color and single green color, single blue color itself, it will contain separate ranges. Okay, so I hope you understood separate ranges, and it will contain a separate intensity of, for red color only, a separate intensity of intensity range, I mean 0 to 255. Okay, so for green also same thing, 0 to 255 separate intensity will be formed. So next thing is gray image. So what is gray image? Gray image is nothing but you can see the X-rays, CT scans, etc. Right? So maximum images will be image processing will be this gray image image only. So this format only will be using. So gray image is a single array. Okay, single array, and it will create according to that intensity of the color, and its range is calculated. This intensity of range same 0 to 250. So 0 to 250 is the bit range. Okay, bit range of sometimes it will vary according to the contrast. According to the contrast color, it will vary. So it comes up to 255 to 256 or 257. Next one is binary image or bilevel image, or you can say black white image. So this is the binary image or bilevel or black white image. Okay, so this is the range. One is like a binary, as we all know about a binary numbers, right? So same thing, zeros and ones we are using. Okay, so 0 means black and 1 means white. Okay, for this intensity range, 0 is black and 1 is white. So this is the RGB color. Okay, this is the RGB red, and according to the red, green and blue, according to the previously I already told you that RGB will be by adding colors. RGB will be formed by adding the colors and change the intensities. Okay, so this is the gray color image. So this is the gray color image. It is formed intensity of the bit range. It has 8 bit. Okay, so this is, I told you, single channel array. So its range is 0 to 255, or sometimes it will be varying. Okay, so according to the contracts it will vary. 256 means 256, 257. So till 2 point or 3 point will be vary. So this is the binary or black and white image. So binary or black and white image. What is binary? I already told you. It black is 0 and white is 1. According to this it will vary. Okay. So introduction of image processing. So image processing is nothing but which is used to enhance the image and which is used to extract more information from it. So image processing is analysis and manipulation of digital images. First we have to enhance the image. Okay, so for that purpose only we are using the image processing. So what purpose of why we have to go with image processing? What is the purpose of image processing? First we have to visualization. For image processing is divided into several groups. So one is visualization group, and another is image sharpening and restoration, and another is image retrieval, measurement of pattern, and image recognition. Okay, first visualization. I told you visualization purpose. So what is visualization? So sometimes it will not, the object will not be observed properly, or it is not will be visible properly. For that purpose we are going to visualization purpose. Okay, so next thing is image sharpening and restoration. So why we are creating this image sharpening and restoration? To create a better image. Okay, for edge edge and all we have to create properly. So image sharpening and restoration is used to create a better image. Next one is image retrieval. So image retrieval is image interest. Okay, so image interest, we are go with the image retrieval. So next thing is measurement of patterns. So we have to observe the object first, image first, and we have to measure the various objects in the image. Next thing is image recognition. So image recognition is just used to distinguish the images. Okay, so image is nothing but I already told you two types of image. One is analog image and second one is digital image. So this is the analog image. What is analog image means? We are capturing the pictures. While capturing the picture, that is analog. When you are going to save, after saving the picture, it converts the you are saving in a digital. Okay, so that is the digital. After saving in a so that is the digital image processing. First we have to give an input. Input is an image. After that we have to pre-process it. What is the pre-processing means? Filtering purpose and all we are going to use. So without pre-processing we couldn't use this technique. So after this using techniques we have to go with the output. So this is the digital image processing. So we are taking the picture and saving in a phone. So after saving the phone, it will converts into the matrix. Okay, so pixel size, conversion of matrix into the pixel size, that is the digital image. Okay, so rows and columns, I told you pixel is a combination of rows and columns that will be convert into digital image, saves in a digital image. So we have to pre-process and we have to classify whether it is apple, banana or grape. Next thing is general types of digital image processing. So general type of digital image processing. So we have 5 types, right? So one is morphological image processing, Gaussian image processing, Fourier transform in image processing, wavelet image processing, and image processing using neural networks. Okay. So first thing we are going to see one by one what is morphological image processing. So morphological image processing is just generally concerned with shapes and properties. Okay, so we have to if you are giving the object that means for image, so we have to concern with shapes and properties of object first of all. So which is used segmentation and feature extraction. This morphological image processing which is used for segmentation and feature extraction. In this morphological process, it contains two basic operation. One is dilated image and eroded image. Okay, so erosion and dilation, this is the main two basic operation we are using in morphological image processing. Okay, first thing, what is dilation process? So dilation is nothing but which is used for add pixel to the boundaries of object in the image. So we have to add the images in the boundaries. Okay, so which is add the pixel to the boundaries of the object in the image, that is dilated image. Okay, next thing is eroded image. So it is used to remove the pixel. So you can see the difference between the dilated image and eroded image. Okay, so first thing, here we are going to add the images and here we are going to remove the pixel size of the images in the object boundaries. So what is the structure and element of the morphological image processing? So a pixel will be added or removed from the object, that is the image depends on the size and shape of the structure. Okay, which is used in this image. So we are going to add the size and shape. So that is the thing, whether it is morphological image processing, which is used dilation to fill the holes. So suppose if you are giving the image, so in that image we don't know what it's having. Suppose if you have holes, means we have to fill that image, and we should smooth that object of boundaries. So that is, if you are doing that process, means we are going to add some extras. So automatically the image will be maximum. Okay, same like erosion, means it is used to remove the isolation noise. Okay, so isolation noise pixels you are going to remove. So you can see the difference in between this test and this eroded image. So smooth the object boundaries. Both dilation and erosion will give clean image. Okay, so but the difference is, if you're going with a dilated image, means the image will be image size will be bigger or smaller, eroded image. So that is the difference between morphological image processing. So next thing is Gaussian image processing. So Gaussian image processing is which is application of Gaussian filter. Okay, for filtering purpose only we are going to use this image, Gaussian image processing, purpose of smoothing and removing the blur. Okay, in this type of linear filter, which is we are going to use linear filter only to reduce the noise and remove the high frequency and create a softer appearance. For that purpose only we are go with Gaussian image processing. So after that we are going to use the via edge removing noise also. So for filtering purpose only you are going to use this Gaussian image processing. Next thing is Fourier transform in image processing. So what is Fourier transform? So this is kind of a mathematical tool. Okay, so mathematical tool which is used in image processing to analyze the frequencies of content in that image. So we can analyze the frequency of image, which is mainly used where the pixel values are represented as the function of frequency. This Fourier transform waves is which is used for a spatial domain. Okay, so this is spatial domain which is used to reference the patterns. Okay, intensity variations and all we can use with this spatial patterns. So why we are going with spatial domain equivalent, means we are going with to check the intensity variations. Okay, intensity variation, edge, texture, patterns and all we are going to vary. Next one is wavelet image processing. So what is wavelet image processing? Means it is the technique which is used to analyze and process the transformed digital image, which is used to analyze the image. First of all we have to analyze the image before going to the process. So first we have to analyze the image, after that process and transfer digital image. This is also some mathematical tool operation functions, and whether it can be represented in single image signals and image various scales and resolutions. Okay, various scales and threshold process and all we can use with this wavelet image processing. So Fourier transform will be providing only information about the frequency of the content in the image, but this wavelet transform is both performing both frequency and spatial information will be containing in the image. So So image processing using neural network. So image processing using neural network. So not only image processing domain is using in the MATLAB, we can use in the neural network also. So neural network means it comes under the deep learning. So deep learning and image processing, there is a differences between the deep learning and neural networks. Okay. So fundamental image processing steps we are going to see now. So first thing is image acquisition. So what is image? This is the key stage of image processing, right? So key stage of image processing, what are the key stages? And we can say about fundamental image processing. Okay, so pre-processing steps has image acquisition. First of all, we have to go with image acquisition. So what is image acquisition? So in image acquisition, we can use to take picture. For example, you can take a picture of trees. Okay, so that is the analog image. While taking the picture is in the form of analog, and while you are saving the picture, it will, as I previously said, that picture will convert into digital with the combination of rows and columns in the pixel size. Okay. So data acquisition is nothing but, so that is a two-dimensional image. Okay, combination of two-dimensional image is called digital image. So next thing is a pre-processing image. We have to pre-process the image. Why we are going to pre-process the image means we should reduce the complexity and resize and reshape the image. Okay, so that's why we are going with pre-processing. So filtering process. So filtering process, which is used for, we have some harmonics, so that we have to smoothen the image with low frequencies, and we should enhance the image quality. So that's why we are going with filter process. So this is the image enhancement. So image enhancement is also which is used for improve the quality of image. Okay, so this is the contrast, brightness, and we are going with this image enhancement. So this is the segmentation. So image segmentation is nothing but which is used to sets of pixels. So this is the segmenting the image. This is the original image, and we are going to segment the image with several sets of pixels. So this is called several sets of pixels, and this is called the superpixels. Okay, which is used to analyze the image very easy. So that's why we are going with image segmentation to locate the object of boundaries. Okay, so that is the image lines and curves. In that image, it will segment the image for easy analyze. So next thing is image edge detection. So edge detection is nothing but this is one of the technique which is used for image processing to identify the points in the digital image. Okay, so this is the digital image which is used to identify the points. So which is used to change and sharpness the image brightness only. So according to the edge according to the boundaries it will detect the edge image. Okay, so next one is image compression. So image compression is nothing but which is used to reduce the amount of data. Okay, amount of data we are going to use a lot, so we going to reduce that data. So in that image we are going to maintain its visual quality. Okay, for that only we are going to, this is the original JPG image, so we going to reduce the image for visual quality. Okay, so image compression is vital, so which is used for various purpose. You can store efficiently and bandwidth conversion, faster processing, and we can go with that image process compression. Okay, so next thing is image recognition. So image recognition, why we are go with the image recognition means if you are going with the machine learning and computer vision means techniques, image recognition will be using a lot, which is used to train the model and classify the object according to the patterns. Okay, so we have to classify that image in patterns. Okay, so according to that patterns only we have to recognition its value. So here it is local binary pattern, gray level, co-occurrence matrix, and Gabor filter. So for that purpose only we are going to identify the image recognition. So this is the image pre-processing applications. So what image processing using MATLAB, where we can real-time application where we are using this image processing. Okay, so first thing is face recognition, and second thing is number plate recognition, lane departure warning, automatic parking, driver monitoring system, forensic documents retrieval, forward collision warning, traffic sign recognition, and film industries. So we are going to see one by one. Okay, so for face recognition, for security purpose only we are going with face recognition for security purpose. So your face recognition, cryptography, steganography, and watermarking and all, we are go with face recognition. Okay, so this is the cryptography. So this is one method of application of cryptography method, and the second one is steganography method. This is one also the secret message will be passing. So according to the secret message, this is also one, according to the secret message it will be working. Okay, so this is steganography method. Second one is watermarking. So this one is also invisible signature will be giving. So this is also for secret purpose. So this is image fusion. So multi-sensor will be using in this image fusion. So image fusion methods, we have a lot of image fusions method. So three types of image fusion method is average, pixel, and color analysis method. Okay, next one is biometric method. So biometric method also we can use this image processing technique. So next one we can use this image processing technique in medical domains also for analyzing the disease. Like I told you before that we can use the grayscale image. So this is the CT and CT image and X-ray sheets. Okay, this is MRI images we are using. So we can analyze and cluster the part of the which diseases Each area is disease is diagnosed. So we can, here we are used a threshold, region of interest and clustering method. So we can identify the disease very easy. So this is image enhancement. Okay, so image enhancement I already told, spatial domain method and frequency filtering method. So this is the histogram of image, which is, this is the waveform of image process. So this is the denoising image. So if you have any harmonics and filters, you have to denoise the image, and this is the blur image, and after that pre-processing denoising image, your image will be with visualizing quality. Then next thing is image restoration. So image restoration is also same process. So this is the normal image, original image, and after restoration it will be for visible part, okay, with the high enhancement quality image. So this is the image restoration. So next thing is MATLAB. So MATLAB is nothing but some multi-programming language and numeric computing environment. Okay, so it is a matrix manipulation. So several types of programming languages can be used in image processing. So Python, C, C++, MATLAB. So lower languages, machine languages and assembly language. So we are going with MATLAB. Okay. So as I told you before, it's a programming numeric computer platform. So about matrix laboratory. And background review is Winston George, origin of MATLAB. In 1980, MATLAB was written in C first of all. Then in futures of MATLAB is MATLAB works in the three main forces. Okay, one is the mathematics, graphics and programming. Second one is, it is a high level languages which is mainly used in engineering and scientific computing. Okay, so next thing is, it is used for visualizing the data, okay, in the graphics forms. So and we can several toolbox installation of Matbox we are having. So fundamentals of MATLAB programming is, we are going to use this MATLAB programming is C. So this is the basic desktop tools: command window, editor window, workspace and current dictionary. Okay. So this is the MATLAB editor window. So this is the general purpose commands of MATLAB. General purpose of commands. So clear, close, all, save. This is kind of C only. So MATLAB functions. So for scripts, the MATLAB functions are similar to the scripts, and MATLAB functions may take some arguments also, and return functions like C only. And this is some graphic functions. And this is some elementary matrices. So I have ones, zeros, magic run, and this is on the MATLAB functions code we are using. So save and load the variable. So this is some toolbox on the MATLAB. So we have a lot of toolbox on the MATLAB. So according to the toolbox, according to our project, we have to install the toolbox on the MATLAB. Okay. So toolbox will be vary according to the project. Next thing is MATLAB applications. What are the applications of real-time applications we are going to use in this MATLAB? One is embedded system, then another is control system, digital signal processing, wireless communication, and image processing and computer vision. Simulink in MATLAB we can use. This is the image processing on MATLAB. So this is image processing on MATLAB. So this is the digital image processing is the use for computer algorithm to create, process and communicate the digital images. So as I told, this is Candy edge detector. So according to the edge detector, it will detect and remove the noise and improve the quality of the image. So this is the image conversion. Okay. So this is the binary and so this is the GUI graphic user interface. So basic GUI elements: checkbox, buttons and label buttons, radio buttons, slides. Thank you. Any doubts?